Okay. Well, thank you very much, everybody, for the opportunity to present. Today, I'm going to be introducing Swarm feeds. I see that in many of the presentations, it's been mentioned as a building block for something else, and that's great. Also, I'm just representing the work that the Swarm team has done up to get to this point, and then I join and I'll help move this module ahead a little bit too. So yeah, just a little bit about me. My name is Javier Peletier. I'm the CTO at Epic Labs, and we are a 3-year-old company innovation center in Spain. Just a little bit about the agenda today, a little bit about Epic Labs. Then we're going to be talking about what are Swarm feeds, how do Swarm feeds work, how do I use Swarm feeds, and then an API introduction so you guys get familiar with how it works, what are the things that are underneath, and then a few demos that I think will help illustrate this better. Okay. Okay. So just a little bit about Epic Labs. We're a team of 25 engineers in Madrid, in Spain. We're a software innovation center. We help medium to large companies innovate. We're experts in video and video over the internet, encoding and machine learning applied to video technologies. But also we have a part of our company dedicated to blockchain consulting services and training. We're building also Ethergit, which is a tool to decentralize open source collaboration. And in starting with this project, we finally started to contribute with the Swarm team. Okay. All right. So Swarm feeds. Let's go to the meat of the presentation. So what are Swarm feeds? Anyone would try to come up with a definition for this, or? Okay, it's cheaper than ENS. Another thing, another definition. Anyone? Okay, I'll try, because I don't think we start doing the work and then we try to define it, okay? So I think we could define Swarm feeds as a microblogging platform, or a microblogging platform building block, okay? And as such, it allows you to post updates about a certain topic, okay? But you can also read other people's updates about that particular topic, okay? So the focus of feeds in here is do one thing and doing very, very well, okay? So think about a microblogging platform where you can post updates and you can read other people's updates, okay? If we want a more academic definition of this, I would go for this one. It could also be a key value store, okay? Where each user can only write to their own key space, okay? So of all the possible keys, you would only be allowed to write to some of them, okay? And you can call that that key space your own, okay? But you can read yours and other users' key space, okay? So you could consider Swarm feeds like a key value store somehow. But it also has the property that you can retrieve older versions of a value, okay? If you provide a time parameter, you can also read all values, okay? So how do we address feeds? How do we refer to a feed, okay? A feed is addressed only with 2 things. Remember this, only 2 things. The user's Ethereum address, that's one of the things that you need. And you also need a topic, which is a 32-byte array, anything you consider, okay? And this is a more Golang definition of what a feed is, just 2 things, a topic and a user address. So there's 1 feed per topic per user, so infinite possible feeds, okay? Just imagine that you have a Twitter account for every possible topic. And actually people do that, right? Some people create a Twitter account to talk about what they do in their work. Some other people just create another account just to fool around and not, keep things separate. Okay. So imagine that you have like this possibility of having like a Twitter account for every possible topic. Okay. So what are the things or benefits that you can do with feeds? You can instantly alter content in Swarm without on-chain transactions, okay? As Ilya just mentioned before. You can enable dApps to persist content very easily, okay? So you have a Dapp, it runs on maybe 100% on HTML, and you want that application to save something and then retrieve it, okay? You could use Swarm feeds to that. You can also quickly retrieve older versions of content. You just need to say, okay, I want the content, or I want this feed as if it was like 3 days ago, for example, and you'll get the value, okay? And it also enables social type decentralized applications, like, for example, unstoppable chat. Or additionally, Ethergit is completely based on this. And also we're working as a proof of concept on some sort of like a decentralized YouTube. But it kind of binds well with this type of social applications, okay? Interestingly also, I think it also enables decentralized Internet of Things. And we'll see that in a few slides. So just let's look at an example of how this would look like, okay? So imagine that we have 3 users. Each of them has each of them has their own address, okay? And then you also have topics, okay? A topic could be avatar, like a profile picture kind of thing, local weather, or website, okay? And some of the users start posting updates to that particular user. Is going to be posting an update on her avatar or his avatar, okay? And they're going to say, okay, my avatar is this picture, okay? So this means that if you query the feed, giving the user address and the topic, you're going to get the image that the user posted, okay? If you query another user and a different topic, you're going to get the corresponding value. So that's what I meant when I was saying that it looks like a key value store, okay? You can store something under a key and retrieve it back. So what happens the next day, for example, somebody makes an update, user A changes the profile picture, okay? We can now, if we query the same thing, user and the same topic, we're gonna get the new picture, okay? But if we incorporate a time parameter and say, for example, that I want the profile picture as if it was yesterday, okay, I'll get the older one, okay? So it's a key value store with the time component of being able to retrieve an old version referring to it by a timestamp, okay? Okay, so what are the things that you need to do to post or read in a feed? So to post to a Swarm feed, you need 2 things, as we said before. You need a private key to sign your update, and you need a topic, okay? To read, you need the user's Ethereum address and the topic, okay? So I'm repeating this because it's important to get the concept as it's as simple as that, okay? And if you want the older post, you need a timestamp, okay? So what is the topic? The topic is just a 32-byte array. And how you get to that array is completely up to you, okay? That topic could be a hash of something, okay? It could be a fixed string, like avatar, as we saw in the example before, okay? Just make sure that people can get to that topic somehow, okay? Either because you publish it for everybody, that you're going to be publishing under a particular topic, or that you tell them, okay, the topic is going to be whatever this and whatever that, we hash them together and that's the topic, so that we have a meeting place, okay? So for example, if it's known that people post their profile picture to the avatar topic, then once we see a user address, I could see that user address, then get the word avatar, okay, and then retrieve the picture. For example, if I had a wallet application and I see that incoming transaction that somebody paid, okay, I could do a lookup on that address, okay, with a particular topic, maybe user information or something, and then I could retrieve information about that particular user, okay, just by knowing their address and a set of well-known topic names, for example. Okay, let's talk about the feed payload. What are the things that you can put on a feed, okay? A feed payload is limited to 3,963 bytes, okay? There's a constant encode that will give you that value, okay? That's because a feed is just a Swarm chunk, which is 4K, and then we have to add some headers and stuff, so that leaves it to 3,963 bytes. But in general, you will want to post to the feed the hash of the actual content, not the actual content, because the actual content you're going to be limited to the 3,963 bytes. So usually you will upload something to Swarm the regular way, okay? Get a hash and put that hash in there, and then you have plenty of space to put it there, okay? Okay. There's also a concept of feed manifest, okay? This is somewhat optional to deal with feeds, okay? A manifest is just a JSON that contains the bare minimum information to look up a feed. And that is, again, the user Ethereum address and a topic, okay? And this JSON can be uploaded to in a regular way, okay? Like Swarm app. And then you obtain a hash, okay, that you can use within ENS or BCC protocol. This is how it looks, okay? It's just a topic and a user. That's all it's got in there. And for example, in this case, what we have in here is the word website X encoded right there, okay? So that topic would be about website information. So how does this work with ENS? Okay, so before we had feeds, what we had to do is get some content, okay, and do Swarm up, okay, and that we would receive the hash of a content manifest, okay, a JSON, and then what we would do with that hash is do a ENS Ethereum transaction and pay the fee and have that hash be stored in the blockchain under that name, for example. So it means that when I want to update, I need to, again, upload the content as before, okay? I get a new content manifest JSON, okay? And then I have to do a transaction to change that pointer. And then this would be forgotten, maybe, but the content, I mean, the site will point to the new content, okay? That's how it works without feeds. But with Swarm feeds, you first need to upload the content. You get a content manifest JSON. You publish this under a feed, okay? And then you take that hash and you put it on ENS, okay? You have to do one transaction just to set up ENS. But the benefit is that subsequent updates will not have any transaction cost. So you will have this, and then you want to put new content. You will upload the new content, get a new manifest JSON, and then change that pointer at this level, okay? Which means that there's no interaction with ENS, and that means no transaction cost in that sense. Okay? Let's take a look also at the HTTP API. To read updates, to read an update, we said before that the only two things that we need is the user address and the topic. So the API is going to tell you, I need a topic, okay, and I need a user address, okay? And if there's an update, okay, you will get a binary response, HTTP response, okay? To post updates, it's a little bit more work, but first you need to learn the feed status, and you can retrieve it with this extra parameter, okay? And it will tell you what is the feed status at this point, okay? And then with that feed status, you build this big query string and post the update through that, okay? The complex thing about this mostly is calculating the signature. I will try to help explain that in next slide, but this is a work in progress to simplify that signing process. So in the Go API, to read updates, you need to construct a query object, okay, in which you indicate the user and the topic, okay? Then you just call a client query feed with that query object, and it will give you IO reader with all that information, with the information that is posted. To post updates, you need to use that query object to get a request object in which you are going to be able to attach the data that you want to publish and sign it, okay? And with that, you can call update feed. So all this is more or less abstracted out in the API. So signatures, which is a hot topic, okay? So this is the shape that a feed payload has, and this is something that we have to sign. So Internally, it means that we have a version, we have the topic, we have the Ethereum address, we have the time at which we're posting, frequency, and then the data that we want to post. And that is, we have to calculate an ECDSA signature out of that, okay? The Go API does it for you. There's some JavaScript snippets floating around that do this, okay? And hopefully at the end of the DevCon I can publish a C++ version of this, okay? But this is posted in the document. We'll be posting this to the documentation so that it's easier to understand how to implement the signature for feeds. Okay, so we're going to be doing a demo, okay? Step by step. That way, I'm going to get out of here into a more sane OS. Any questions so far? We can take the time it takes to boot. Yes?
I'm a neophyte, okay? I'm not a specialist.
Mm-hmm.
You started your presentation, I got all excited about research. I do research in books.
Mm-hmm.
You do that like that. Many people corresponding and giving many opinions about one topic. Then when you went further, I thought, oh my God, this is complete. I don't get it. Now my question is, what do you use this for?
Well, as I said before, hopefully we can use this this tool as a building block for those applications that will be easier to use, right? Right nowadays we are used to just opening up our phone and using some messaging service, for example, that is already built. Okay, this would be a building block that will allow us to build this application in a more decentralized way, because the regular tools that we have, like WhatsApp, for example, are owned by a big company, right? So this would be a way of helping people build applications that are more decentralized. Okay. Not sure I'm gonna be able to duplicate my display, so this might be a little bit complicated, but the idea here is to post to Swarm feed so you get the idea how this works. Okay. There you go. Okay. All right. Okay, so Swarm is running in the background, so we're gonna go ahead and upload something. Okay. Okay, I have a few pictures in there. So what I'm going to do is I'm going to take one picture and upload it. Okay. All right. Connection refused. Okay. All right. Anyway. Backup plan. Yep. Okay. Yeah, I know what's going on. All right, back on track. Okay, so the only thing that I did was to upload a picture. Okay. And now I'm just going to go some trouble with this. All right. We're getting there. So we have that picture uploaded, okay? The idea here is now how we can change that picture, change that. Imagine that picture represents our website, so we want to just go ahead and update that picture, okay? So what we're gonna do is we're gonna be posting a feed, okay? Okay. Okay, I'm not sure you guys can read the command line I'm trying to do in here, but the command that we're trying to do is just feed update -- topic demo site, okay, which is the site that we want. Actually, sorry. Yeah. I'm sorry? Yeah, sorry. Yeah. All right. Yeah. Good idea. Thank you. Okay. So we have this. Sorry about that. Okay. Okay. So with this command, what we're doing is we're going to create a feed manifest. Okay, as we explained before, that is going to be pointing to my user address, which is 0x7a to e something, and then the topic is going to be demo site. Actually, I'm going to put name, not topic. Okay, the topic is going to be demo site. Okay. And here we go. So this would be a content manifest hash, okay? And so we're gonna go ahead and go to our picture. And this is the address that corresponds to this. It has to retrieve the same picture for now because we didn't change it yet. I'm busted. Yeah. Yeah, maybe try again. Let's see if we're lucky. I'm sacrificing to the demo goals, as Doug was saying before. Sorry, not Doug. Okay, somebody broke my demo. Anyway, so and that's actually right. I didn't update the feed. I just created the manifest. Okay, so I need to update the manifest. I'm going to update the feed. I created a manifest, but I need to really post the picture that we had before. So just back again, get the hash of the picture, okay? And now we're gonna be updating, not creating. Okay. Okay, and that's the hash of our picture. And we're lucky. We will do it. Yes? Okay. All right, so now let's see if this works. All right. Maybe my node is under stress. Okay, sorry guys, I couldn't get it to work. Okay. Okay, just to finish up, we're here. Well, okay, anyways. Okay. Okay, and I also have another demo ready. If I have time, I'll do it. But the idea was to get a microcontroller device to post to feeds. Okay. So what this does is this is a very cheap microcontroller that you can get for €1 or €1.50. Really cheap. It's got Wi-Fi. It's got 4 megs of RAM, and the great thing about it is that you can like build applications with it very cheaply. Not sure if anybody is familiar with the ESP chip. Anybody in the IoT? Okay, so the good thing is that it's so cheap and you can control devices and other things. Okay, so what I set up to build on a hackathon was to see if I could get one of these things to sign to a feed. Okay. And read temperature information and post it to one of the feeds. Okay. So I'm gonna just plug it in right here, so that it has power. Then I have to give it internet access somehow. So I'm gonna share my phone Wi-Fi. And I hate you. All right. Okay. So this is it working actually. It's reading the temperature from the room, although my sensor is not very well calibrated. This is the time since I took on the plane, and so there's no readings. Okay. But as you can see, this is starting to pick up some measurements in there. The way this is working is that this device is just reading the temperature from a sensor, packages into a feed, posts it to Swarm, and then this web application, as you can see, is hosted on Swarm gateways. On Swarm is just reading that feed to plot this graph, okay? And also, since real time, this is publishing information, it's starting to get new data points, okay? Trick is if I touch the sensor with my finger and we wait a little bit, the temperature will increase. So it's a way of saying that the information is being moved to Swarm. So hopefully it'll work, because that information is not being made up. So okay, it will work. Yes. Maybe. You see? This is hot. Okay, I'll leave it at there. All right, so that was a good question. Yeah, that's right. I know. My sensor is just not good. All right. Okay, so areas of improvement, and with this I finish. We need to accelerate that lookup algorithm. So some of the bugs that you have seen maybe relate to that. We need to simplify how to sign feed update. We like to have an official JS client that everybody can work with. Improve the HTTP API, which has complexities, okay, and potentially, you know, have a way to add a user mount point. This is hard to explain, but it would allow to browse feeds much more easily under that BCC endpoint. And with that, thank you very much.